All right, y'all, last 2 pages. So this is module 4. So make sure you pay close attention. Module 4 did not go well for a lot of students as far as the test goes. And it is covered on your final and will definitely be needed for next year. Okay, so remember that a piecewise function is in pieces. It's a line that's in pieces. So you've got 2 right here. You've got 4 minus x, which is the same as negative x plus 4. And then you've got 3x minus 6, which is already in mx plus b form. Okay, so let's go ahead and graph the first one. Notice it's less than 2. Right here it says x is less than or equal to 2. So that's where it's going to stop. So negative x plus 4, I'm going to go up 4 and make a point. And then it's a negative slope. And I'm going to stop at 2 right here. This is 2. And it's a closed circle since it has a less than or equal to. Now the other one also stops at x is greater than 2, but it doesn't have an equal sign, so that one's going to be open. So I'm going to go down to negative 6. 1, 2, 3, 4, 5, 6, right there. And then I'm going to use a slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, etc. Now this one starts at 2, and it's going to be an open circle. So that means I'm going to go ahead and erase these because it hasn't started there yet. It started right there. And it is an open circle because it has a greater than. So greater than or less than, it's going to be an open circle. Greater than or equal to, less than or equal to, is going to be a closed circle in case you forgot. All right, so this one we're solving absolute values. You're going to get 2 answers for these. Now, the first thing we want to do is get the absolute value by itself. So we're going from the outside in. We're going to subtract 9 first. So we're going from the outside in. You want to get rid of this 9 first. And then we're going to divide by 5. And we get 3x minus 6 equals 27. 3x minus 6 equals 27. That's going to give us one answer. 3x minus 6 equals negative 27. That's going to give us the other answer. Okay, so you've got 2 answers right there. And for problem B, we're going to do the same way. We're going to go outside in. So you want to get rid of this 15 first before we set up both of our equations. So 4x minus 5 equals 21. 4x minus 5 equals 21. I leave that alone. And then the other one, I'm going to make a negative 21. And then I'm going to go ahead and solve for x. So I added 5. That's why 21 plus 5 is 26. I divide by 4. And it's okay if you get a fraction. Just make sure you reduce it. That one is going to be 13 over 2. And over here, we add 5. And we get negative 16. And this one's going to be a nice solid x equals negative 4. Okay, let's look at C. So you want to go outside in still. So we're going to get rid of the 4 first. 5/8 times 2x minus 4 equals 5. And then we're going to get rid of the fraction. So how do you get rid of a fraction? You multiply by the reciprocal. Don't let fractions scare you. You're just going to multiply by the reciprocal. Over here, they cancel out. You get 2x minus 4. And then these end up canceling out, actually, and you just get 8. But we have to come up with our two equations. So 2x minus 4 equals 8. I add 4. I get 2x equals 12. I divide by 2. I get x equals 6 is one of my answers. And then the other one is 2x minus 4 equals negative 8. I add 4. 2x equals negative 4. Divide by 2. And x equals negative 2. Okay, so you should get two answers for all of these. If you end up getting something like, for example, x minus 5 equals negative 2, that is when you have no solution. Okay, so when you have the absolute value and it is all by itself, there's nothing outside, there's nothing to add, subtract, divide, or multiply on the outside, and it equals a negative, that's when you write no solution. So it's got to look like a V. It's either going to be a V or a mountain. Okay, now since this is positive, it's going to be going up. Okay, you want to start with your vertex. Remember that you always switch whatever's in here, you switch the symbol. So it's minus 3, you're going to make it a plus 3. And on the outside, it stays the same. So that is my vertex right there. 3 and then up, down 7. Okay, and then 5/4. Okay, that right here is my slope. But you have to end up having a V shape. One of the problems that students do is, one of the common mistakes is they go up 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Okay, that would be my next point. 1, 2, 3, 4, 5, and the other one would be like here. And then they draw a straight line. That's not supposed to be a straight line. It's an absolute value. So what happens is you're going to do it to the right, and you're going to do it to the left. 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 5, 4. Make sure you draw that line all the way across. Okay, so notice this one has a negative. So this one's going to have to look like a mountain. Okay, we're going to start with our vertex. So negative 5, because it's the opposite sign. Since you see a plus 5, that means it's subtracted a negative. And then 4. That's my vertex. So I'm going to draw my point at negative 5, 4. And then my slope is negative 2. So I go down 1, down 2 over 1, down 2 over 1. I'm just going to keep going all the way across. But remember, it's not a line because it has those absolute value symbols. So you're going to do it to the right and you're going to do it to the left. And then you're going to draw your V. In this case, it's a mountain or upside down V. All right, inverse. So when you see that symbol, that means inverse right there, that negative 1. Okay, so the first thing you do, remember, is that you switch your x and your y. F of x is just y. So that's the same thing as that, but we're getting fancy with the math notation. So that's why we write f of x. But remember, we're going to switch the x and the y. So that's the first step. Instead of writing x, I write y. Instead of writing y, I write x. And then I'm going to go ahead and solve for y. So I'm going to subtract 5. I've got x minus 5 equals negative 4y. And then I'm going to divide by negative 4. And y equals x minus 5 over negative 4. That's one way to write it, but you're more than likely going to see it like this. Y equals negative 1/4 x minus 5/4. And since it's a negative at the bottom as well, then it's going to turn into a plus. And we write it like this because that's in y equals mx plus b form. But we got to fix the notation. So instead of y, we're going to write f negative 1x because that's how you write your inverse. Okay, over here, same thing. So y equals blah, blah, blah. We're going to switch our x and our y. Now, you have to remember that you're going to go from the outside in. So I'm going to move this 5 first. Before I do anything, I got to move that 5. Now, don't get scared of fractions. All you have to do is multiply both sides by the reciprocal. So 7/3. And this whole thing will be times 7/3. Okay, so right here they cancel. I get y plus 1. And then over here, I'm going to go ahead and distribute that 7/3. So 7/3 x plus 35 over 3. And then the last thing I have to do is subtract that 1. That's a number. So these right here can combine. You can just plug it into your calculator. And then you will get y equals 7/3 x. Stays the same. And then plus 32 over 3. And I've got to fix my math notation, so I'm going to write f negative 1x. Okay, again, that's y equals that part of the equation. And then we're going to switch my x and my y. You're going to go from the outside in, so I'm going to subtract 3 first. The opposite of a squared is a square root. So I'm going to go ahead and take the square root of both sides. Now, when you take the square root, you're supposed to put plus minus. And then the last thing I got to do is just add the 4. So I've got y equals 4 plus minus the square root of x minus 3. And I got to change my notation. So instead of y, I'm going to write f negative 1x. All right, last two problems. This looks complicated, but it's actually much simpler than the previous problems. First thing you've got to do is let's make a chart x, y. And we're going to go ahead and put our points on here. And right here, I've got 5, 1. And then right here, I've got 3, 5. 1, 4. Negative 3, negative 2. And negative 5, 2. And I don't have another point. And so what you do is you're just going to make another chart. And you're going to flip your x and your y. So 5, 1 becomes 1, 5. 3, 5 becomes 5, 3. That becomes 4, 1. Negative 2, negative 3. And 2, negative 5. And now we're going to go ahead and graph. This right here is the inverse. And this over here is the original one. Okay, so let's go ahead and graph it. 1, 5. 5, 3. 4, 1. And I'm just going to check these off since I've graphed them. Okay, negative 2, negative 3. And 2, negative 5 would be about here. So you got to follow the shape. I know it looks like random dots, but like there's a line going that way. That line's the reflection of that one. Then line going that way, and that's the reflection of that one. Then right here I can see I miscounted. 5, 3 should be right here. And I could kind of tell because it looked a little bit longer than this one over here. I'm erasing those so I can see the rest of it. And then that extends all over there. So it looks funny, but it is the reflection. And it's the reflection on y equals x. So it reflects on this line right here. Okay, and last problem. So look at this right here, and then you always want to change the inside. So you see a +3, that's going to be a -3, and then the outside stays the same. So this is where the point's going to start. So at -3, 1, that's where my square root is. And a square root is going to look like this, a sideways parabola, but it's only either the top half or the bottom half. Okay, this would be a positive square root, and down here would be a negative square root. So this one's going to look like this right here. Because it's a positive on the outside of the square root. Okay, so at -4, I'm not going to have a point. So I can just do a little dash. I don't have a point at -4 since it starts at -3. At -3, I have a 1. At -2, I'm going to go ahead and plug that in. And I get 1 plus 1, which is 2. And then I'm going to go ahead and plug in 1. So the square root of 4 is 2, and then that's 3. And then I'm going to change that to 6. Now, if you didn't notice, those were all numbers specifically used so that you get a perfect square right there. Okay, so that is why the numbers might not necessarily make sense at first, but if you notice, every time we plugged in a number, we got a perfect square right there. Now, you can do it this way. Another way to do it is to graph your original function first, which would be 0, 0, 1, 1, 4, 2, 9, 3. That's your original. And then you would move to the left 3 and up 1. All of those points would move to the left 3 and up 1. And in case you're thinking, well, where did she come up with that's the original? Well, the original is just the square root of x. And so if I plug in the square root of 0, I get 0. If I plug in the square root of 1, I get 1. Square root of 4, I get 2. And the square root of 9, I get 3. Okay, so that's where you get your points from. 0, 0, 1, 1, 4, 2, and 9, 3. So those are two different ways of graphing. But it will still be the original, it will still be the same point. So it'll be that one. And now let's look at the domain. And my domain, okay, where does my x start? My x starts at -3, and it is a solid point, so that's why I'm going to use a bracket. And it keeps going to the right forever and ever and ever, so that's why it's infinity. Okay, range goes from bottom to top. The lowest that it goes is at 1, and it keeps going up consistently, so that's infinity. Your x-intercept, remember that y equals 0. Your y-intercept, remember that x equals 0. So let's take a look at where that is. X-intercept, y equals 0. There isn't one. See? It would be right here, and there isn't. So x-intercept, I just put NA. Y-intercept is where x equals 0. So I'm actually going to have to plug that in. If you look right here, it's in between 2 and 3, but I don't actually know what that is. So I have to plug in x equals 0. So it's the square root of 3 plus 1, which would be a decimal. So let's just keep it as square root of 3 plus 1. Okay, does this have a lowest point or a highest point visible? It has a lowest point, and you can either write -3, 1. You can write the entire points, or you remember that you would just use your y value. So I would just write 1. Increasing, remember increasing, it's a positive line. So this is an increasing shape. This is a decreasing shape. You got to look at the end behavior. You'll learn about that next year in Math 3. So end behavior. And it looks like it's going to be increasing. So it's not decreasing. We can write NA for that. And then for increasing, we just write similar to the domain. You're going to start at -3. You're going to end at infinity. But with increasing and decreasing, you only use parentheses. You don't use brackets.